Assalamualaikum and good day. My name is Siti Fatimah Binti Haji Ahmad Zabidi. I'm one of the lecturer from Center for Mathematical Sciences, University Malaysia Pahang. I'm teaching Applied Calculus BUM 2123. So in this video, I'll teach you 1.1 parametric equation. So you should be able to sketch the parametric equations and also to show the orientation. 1.1 parametric equations. By the end of this section, students should be able to sketch the curve by plotting, find the rectangular equation by eliminating the parameter t, sketch the curve of the rectangular equation, and determine the orientation of the parametric equations. Definition 1.1.1. Suppose a particle moves along a curve C in the xy plane such that its x and y coordinates as a function of t are x equivalent ft, y equivalent to gt as shown in the figure 1.1. These equations are the parametric equations of the motion for the particle, and c is the trajectory of the particle. The variable t is the parameter of the equations. The direction of increasing value of the parameter is called the orientation. The curve together with the orientation is called the parametric curve or the graph of the parametric equations. What I'm going to stress here is the variable t. Okay, the variable t is the parameter. So you see here, the parameter is the parameter t. But sometimes you also have parameter s. So if we have parameter x, then x is equivalent to f s and y equivalent to gs. Okay, so parameter can be any value, any variable. It can be t, it can be s, it can also be theta. Okay, now another one is the direction or orientation of the parametric curve. So direction will follow the direction of increasing value of the parameter. If t is the parameter, then it will be the direction in which the t value is increasing. Okay, the word here is parameter direction of increasing value of the parameter. So that will be the orientation. Okay. Analogously, if f, g, and h are all well-behaved functions, then the parametric equations x equivalent to ft, y equivalent to gt, and z equivalent to ht generates a curve in space. That means in three-dimensional system. Now go back to the parametric equation in 2D. So in 2D, x equivalent to ft, y equivalent to gt in the interval t from a to b. So the point f a and g a is called the initial point, and the point f b and g b is called the terminal point. Now let's look at figure 1.1. Now in this figure you have the curve C, and this C is the trajectory of this particle. Suppose the particle moves from that point and along the curve until this point here, and at the time t equivalent to a, the point is here. So initially it is at the point FA and GA. So this is the point FA and GA. So this point is called the initial point. Please take note, T here is from A to B. Okay. So the point here is at the time T equivalent to A. If you imagine T to be the time, the particle is at the initial point. and it moves along this curve here. Okay, as t increases, it moves along this curve here. So you have the arrow, and the arrow is the orientation of the particle, and it ends over here when t value here is b. So FB GB is called the terminal point. Now let's look at example 1.1.1. Sketch the graph of the following parametric equation by plotting the xy coordinate and indicate the orientation. Find the rectangular equation y equivalent to fx by eliminating t from the parametric equations. X equivalent to t, y equivalent to t minus 3, t from 0 to 4. Solution is, you need to, in order to sketch the graph, you have to sketch the curve C and indicate the orientation. First, we construct a table of values of x and y at the parameter value t equivalent to 1, 2, 3, and 4. Okay, so here, to sketch the graph of the parametric equation, we have two methods. One is by plotting. That's the first method. So to sketch the parametric equation, you can plot the point, and it's called method number 1 by plotting. And then another method you can use is to eliminate the variable t from the parametric equation, and you get a rectangular equation. So there are two methods to plot this, to sketch the parametric curve. Okay, let's look at the first method, which is sketching by plotting. So this is the first method. So method number 1 is by plotting. Okay, method number 1, I call it by plotting. So by plotting, you need to plot the points. So in order to plot the points, you construct the table of values of x with certain values of t here. So we choose 0, 1, 2, 3, and 4 as values of t. Now since x equivalent to t, then when t is 0, x also 0. When t 1, x is also 1. When t2, x is also 2. When t3, x is also 3. When t is 4, x is also 4. So for the y value, so we know that y equivalent to 2t minus 3. So when t is equivalent to 0, we see that y equivalent to 2 times by 0 will give you 0. So it will give you 0 minus 3. So y is equivalent to 3, negative 3. So y equivalent to negative 3. So when t equivalent to 1, 2 times by 1 will give you 2. 2 minus 3 will give you minus 1. So y value is minus 1. When t is equivalent to 2, y equivalent to 2 times by 2 will give you 4 minus 3. That will give you 1. So the value of y is 1. When t equivalent to 3, y equivalent to 2 times by 3 will give you 6. Minus 3 will give you 3. So y value is 3. When t equivalent to 4, y equivalent to 2 times by 4 will give you 8. 8 minus 3 will give you 5. So you have all these points to be plotted. Okay. So now we have the table. Just now we have constructed the table, and we try to plot the points. So we plot the point when t is 0 here. The point is 0, negative 3. When t equivalent to 1 here, we have point to be 1, negative 1. When t equivalent to 2, we have that point here. And when t equivalent to 3, we have 3, 3. Okay, the point 3, 3. And when t equivalent to 4, we have the point 4, 5. So we have all the points here. See that as t increases, we know that it's increasing this way. So we will indicate the arrow to show that the orientation of this curve. And this curve is a straight line. Now this is another method, which is I call it method number 2. So method number 2 is by eliminating the variable t from this equation, parametric equation. Remember, parametric equation is x equivalent to t and y equivalent to 2t minus 3. You replace the variable t here to get the rectangular equation y equivalent to 2x minus 3. So we can just plot several points. Probably we plot, let's say, when x equivalent to, now x value is from 0 to 4. So we can plot when x equivalent to 0. Okay, we plot x equivalent to 0, so y is equivalent to negative 3. So we have the point here. Okay, and then we can plot another point, let's say x equivalent to, let's say 2. When x equivalent to 2, y equivalent to 2 times by 2 will give you 4 minus 3 will give you 1. So you plot this point here. And you can plot another point, call it, let's say, x equivalent to 4. So y equivalent to 4 times by 2 will give you 8 minus 3 will give you 5. So we plot this point. Okay, we have a straight line. And the orientation is as t increases. Okay. Now for example 1.1.2, I'll show in class. Now in this video I will show you example 1.1.3. Find the parametric curve of the given parametric equation by eliminating the parameter t. The parametric equations given is x equivalent to square root of t and y equivalent to t minus 1. So if we want to eliminate the variable t here, first you square both sides of the first equation. So then the x equivalent to square root of t becomes x squared equivalent to t. So you know the value of t here is equivalent to x squared. So in the second equation, you substitute the value of t to be x squared. So then you have y equivalent to x squared minus 1. Notice that when you square, okay, you square here, you get y equivalent to x squared minus 1. But in the first parametric equation, t cannot be less than 0 because it's under the square root. So t cannot be less than 0. When t must be bigger or equivalent to 0. So then y is also, so x is also bigger than 0 because t cannot be negative. So if you square, you have to also write x is bigger than equivalent to 0. X must be bigger than 0. Okay. Okay, in the example just now, we have the parametric equation x equivalent to t, x equivalent to square root of t, and y equivalent to t minus 1. So just now we square both sides of equation, the first equation, to get x squared equivalent to t. And we note that t cannot be less than 0. So therefore x cannot be less than 0. So x must be bigger than 0. So we know that t value is x squared. So we substitute that in the second equation to get y equivalent to x squared minus 1. So this is a parabola opening upwards. Okay. So x must be bigger than 0. So we have only half of the parabola. To get the orientation, we need to select several points, several values of t. So in this case, let's choose two values of value t, t0 and t equivalent to 1. When t equivalent to 0, x equivalent to 0 and y equivalent to minus 1. So we have that point here when t is 0. So when t equivalent to 1, x equivalent to square root of 1, which is 1, and y equivalent to 1, t value is 1, minus 1 will give you 0. So we have the point x equivalent to 1 and y equivalent to 0. So we know that the orientation is this way because t increases in that direction. Okay. So in this example, you want to find what parametric curve is represented by the following parametric equations. So we are given the parametric equation x equivalent to cos t, y equivalent to sin t. T varies from 0 until 2 pi. So we construct this table when t is 0, cos 0 is 1, sin 0 is 0. When t equivalent to pi over 2, x cos pi over 2 is 0, but sin pi over 2 is 1. When t equivalent to pi, cos pi is negative 1, but sin pi is 0. When t equivalent to 3 pi over 2, cos 3 pi over 2 is 0, but sin 3 pi over 2 is negative 1. When t equivalent to 2 pi, cos 2 pi is 1 and sin 2 pi is 0. So we can construct the table like this. Now the example 1.1.5, x equivalent to cos t, y equivalent to sin t. So to get the orientation, we need to show this by the arrow as t increases. So we can just look at several values of t here. So when t equivalent to 0, we know the point is at 1, 0. So at 1, 0, x equivalent to 1, y equivalent to 0. So when t equivalent to pi over 2, so pi over 2, we know that the point is 1, 0, 0, 1, sorry, 0, 1. And when t equivalent to pi, point is negative 1, 0. Here, this is the point. And when t equivalent to 3 pi over 2, the point is here, 0, negative 1. So we know that the orientation is following the way by the way that x is increasing. So x increases in this way. So we show this by the arrow here. Okay, increasing that way. So That will be the orientation. Okay. So for example 1.1.6, I'll show in class. In this video, I'll show you example 1.1.7. Find the parametric curve represented by x equivalent to 2 cos t, y equivalent to 3 sin t. We know that cos squared t plus sine squared t is equivalent to 1. So to get rid of this t, we will use this equation. From the first equation, we get cos t is equivalent to x over 2. And from this second equation, we get sin t equivalent to y over 3. So when you square both the cos and the sine, so you square this x squared, x over 2, you square it. This is cos squared t. And you square this one, sine squared t, you get this. So x over 2 squared plus y over 3 squared is equivalent to this. And you know that this is equivalent to 1. So by using this method, you will get x squared over 4, which is 2 squared, plus y squared over 9, which is 3 squared, equivalent to 1. This is an ellipse with the center at 0. Okay, you get this ellipse center 0, and the a value is 2 here. Okay, the a value is 2, so you have 2 here. A value is 2, so we have 2 here. From this one, this is the a value, 2. And the x value, the y value, b value is 3. So you have the b value to be 3 here. So you have an ellipse with the center at 0. So let's look at example 1.1.7 again. We are given this parametric equation x equivalent to 2 cos t and y equivalent to 3 sin t. So from this first equation, we divide everything by 2. So we get this equation. And for the second equation, we divide everything by 3. We get y over 3 equivalent to sin t. And from here, if we square both sides of the equation, we get x squared over 2 squared equivalent to cos squared t. And from this another equation, we square both sides. We get y squared over 3 squared equivalent to sin squared t. And if we add those two equations, we will get x squared over 2 squared plus y squared over 3 squared equivalent to cos squared t plus sin squared t. Okay, so we end up getting the equation x squared over 2 squared plus y squared over 3 squared equivalent to 1. And we know that this is an ellipse. Okay, to get the orientation, okay, before that, look at this, or to get the orientation, second part, we need to find the orientation. We can choose two values of t. Let's say t equivalent to 0 and t equivalent to pi over 2. When t equivalent to 0, cos 0 is 0. Cos 0 is 1. So x equivalent to 2 times by 1, which is equivalent to 2. And sin 0 is 0, so y equivalent to 0. So the point here is 2, 0. Please correct this in the module. There is typing error here. So when t is 0, the point is here. The point is here. Okay. The point is at this one value. This is when t equivalent to 0. The point is here. When t equivalent to pi over 2, cos pi over 2 is 0. So x is equivalent to 0. And sine pi over 2 is 1. So you get value here y equivalent to 3. So the point is 0, 3. So this is the point. So this point at 0, 3 is when t equivalent to pi over 2. So notice that t values increases this way. So orientation should be that way. Okay. So you use arrow to show the orientation. I hope you understand what is the orientation. Orientation is the direction in which the t value increases. Now for example 1.1.8, I'll show in class. In this video, I'll show you example 1.1.9. Now suppose we need to sketch the parametric curve represented by this parametric equation, x equivalent to sine t and y equivalent to sine squared t. So we use second method. Let's say we eliminate the variable t. So if we eliminate the variable t, to eliminate it, we substitute the x value. So x value here is sine t. So x squared is equivalent to sine squared t. So we substitute that in the second equation to get y equivalent to sine squared t, which is x squared. So this is a parabola. So for orientation, we need to actually get the value of t values, but sine t is from -1 to 1, and so x value varies from -1 to 1, but sine t is periodic, so it moves back and forth infinitely along this parabola, the -1, 1 to 1, 1. Okay, let's look at this in the other slide. In the example 1.1.9, we need to find the orientation. We are given x equivalent to sine t and y equivalent to sine squared t. So to get rid of the t, we just substitute. Let's say this from the first equation, we have x squared equivalent to sine squared t. So we substitute in the second equation to get y equivalent to sine squared t is x squared. So we get a parabola. So for this orientation, we can find some of the values of t. Some values of t, let's say we select t to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. So the x value is, sine 0 is 0, so square it, we get 0. Okay. So this one is x value. So x value is sine t. So when t is 0, sine 0 is 0. When t equivalent to pi over 2, sine pi over 2 is 1. When t equivalent to pi, sine pi is 0. When t equivalent to 3 pi over 2, sine 3 pi over 2 is -1. And when t equivalent to 2 pi, sine 2 pi is 0. So we get this point. So y is actually sine squared t. So we square 0, we get 0. Square 1, we get 1. Square 0, we get 0. Square the -1, we get 1. And square the 0, we get 0. So when t equivalent to 0, the point is 0, 0. So t0, the point is 0, 0. So when t increases to pi over 2, the point is 1, 1. So the arrow is going up like this. That's the first from that point 0, T0 to pi over 2, that will be the arrow. The first arrow. And then from pi over 2 to pi over 2 to pi, the point move from 1, 1, okay, 1, 1 to 0, 0 again. So the point is the point is moving this way. So this is the second direction. And for the from t pi to 3 pi over 2, the point is from 0, 0 here until negative 1, 1, until this one. So then the arrow is going this way, going in the increasing value of t. So the arrow is going up. Okay, so this is the third one. Okay, the arrow. And from 3 pi over 2 to 2 pi, the point is moving back to 0, 0. So going back to 0, 0. So this is another arrow. So this arrow is arrow number 4. Okay. So orientation you have to trace along this actually, but because of the two arrows, the two direction, you can write the arrow beside this curve. So you can show the orientation this way. Okay. So for the exercises 1.1, I would like you to do this problem. First part of this exercise is to sketch the parametric curve for the given parametric equation and indicate the orientation. So please remember the orientation is the direction of this curve as t increases. So in the class, I will show to you how to do number 2. Remember, we have two methods whether we want to plot the points, or we can also use by eliminating the parameter t. So for number 2, I use the first method, which is by plotting. So we plot it and then we will get this curve. So I'll show you in class. For number 8, I'll show this also in class. You can use method number 2, which is eliminating with the variable t. So I'll explain to you in class, okay? And for number 15, okay, number 15, we have this curve here, and then I will show to you in class also how to get this curve and how to get the arrow. Number 19, I'll show to you in class also how to get this. For exercise 1.1, I'll be giving you the PowerPoint. For number 9, to sketch. Number 13 also. Number 15 also I'll give you in class. And the important thing here for 1.1, you have two methods of sketching parametric curves. Method number 1 by plotting. So this is useful when you want to indicate the orientation. So probably if you need to indicate orientation, method number 1 is useful. Method number 2 is to eliminate the parameter t. So this is useful when you want to change the parametric equation to Cartesian or rectangular equation. So please bear in mind that you have two methods. Method number 1 by plotting, and method number 2 is by eliminating parameter t. So method 1 is useful when you want to indicate the orientation, and method number 1 is useful when you want to indicate the orientation, and method number 2 is useful when you want to change the parametric equation into Cartesian or rectangular equation. Thank you for watching.